Well, I've started already. What I've got here is a parallelogram. You can tell they're parallel because this angle and that angle are corresponding angles, and they're both 90 degrees. So they're equal to each other. That means that AB and DC are parallel. And likewise, this is 90 and that one's 90. So I know that AD and BC are parallel. And if I have the opposite sides of the figure parallel, it is a parallelogram. And more specifically, since it has a right angle in it, it is a specific type of parallelogram. It is, in fact, a rectangle. But we're not going to be talking about rectangles. We already know if I take the length of this times its width, I'll find out how many squares are out here. And in this case, you'd get 4 in each row, and there's 2 rows, so you're going to end up with an area of 8 square units here. But I'm not so interested in the rectangle. We've already done that one. Let's talk more and more about the parallelogram. But more specifically, I want to pick just a generic parallelogram, not a rectangle, which is sort of special. So I'm going to extend this side here, and let's just reach out a convenient length, and we'll extend it on out over here someplace. Cool. Now I need to have another side here that's not a 90-degree angle. That's a special case. Let's just pick some convenient area, and we'll come over here like this and draw that angle there. And I have no clue. I know that this angle here and that angle here are going to be equal because they're corresponding angles. But that's about all I know. What I'd like to do is I'd like to extend this side down here also. And then we'll come up and we'll make a parallel side down there that is parallel to this one and comes over here. Okay? Well, let's see here. If I want them to be parallel, I have to get the corresponding angles to be equal. And that means I have to measure this angle here. Let's just call it angle 1, so we'll have something to call it. Let's swing an arc through angle 1 and measure it. Just any convenient length will do. And I happen to hit my construction point there, but that's just luck. We're not going to worry about that. Let's come down here and swing the same arc. And then let's measure how much of this arc is cut off by our angle. It's almost 60 degrees, isn't it? Right there and right here. So, and where these cross then, that would be the place I want to draw my line. That would make this line over here parallel to that line over there. And the opposite sides of my figure are parallel, which makes this a parallelogram. There we go. And angle 2 over here will equal angle 1. We've constructed it that way. And I have now ABCD as a rectangle, and I have ABEF is a parallelogram. Now I know the area of the rectangle. It's its length times its width. But the area of the parallelogram I'm not certain about. I'll tell you what let's do. Let's drop a perpendicular from here to there and from here to there, and that would then give us another rectangle we could talk about. Let's take the compass and stretch it out so that it makes the distance possible from here to my line segment AB so that they intersect someplace. Alright, well let's see here now. Let's make it convenient. Let's make it run right through here. Okay, like that. There. And it hits right here and right here. So if I come down here like this, I will have my construction for a perpendicular like so. There we are. That's it. So if I draw a line from here through F, it should make a nice perpendicular for me. From there through F. Boom. That's 90 degrees. Okay, that's cool. Let's call this point, oh gosh, I don't know. Let's call it X. And let's come down here on this side and do the same thing. We're going to extend this side further so we have plenty of room. And I'll draw a arc from here so it intersects my line in a convenient place. That's not too bad. Let's make it just a little bit longer. How's that? There we are. That hits right here and right here. Let's get the other marker. It's easier to see. Right here and right here. And now to make the perpendicular, I need the intersection down here of that arc and this arc here. There we go. Alright. From here up through point E, right about like that, we'll make this a perpendicular. And this one also, 90 degrees. That's what perpendiculars do. 90 degrees. Of course, 90 and 90 makes 180, so it's the same on both sides, isn't it? Well, that's cool. Isn't that interesting? Guess what I've got in here with figure X over to Y, up to E, and over to F. Looks to me like it's another rectangle. And I have a feeling that this angle here equals that angle here. And this angle here equals this angle here. These two are equal, and these two here are equal. And I think, to tell you the truth, we have an excellent reason to think that this one here and this one here will be the same. I think that if we were to measure the distance between parallel lines, that they have to be the same distance apart wherever you make the measurement. So this right here, let's call our height, and this one here would be the height of this one. And that would give us an angle, and a side equal to an angle, and a side. And that means that these two triangles here are going to be congruent to each other. Which means if I were to cut this one off of here and move it down there, that I have not lost anything. And the distance across here would be the same as it would be from there to there. So what I have here now is the base of my parallelogram and its height. This is the same here. That's its height. And from here across to here, let's call that its base. It's going to be the same on the other side down here as this one was from A to B. That's going to be the base of it also. And if I move this down from A to X to here, guess what? That one there is the base there also. That's cool. So the area of a parallelogram is then equal to its base times its height. That's cool. The area of the parallelogram is equal to its base times its height. Well, guess what, guys? If I were to cut this in half by running across here, I'd have a triangle. And that triangle would be half the parallelogram. So this is the area of the parallelogram. And the triangle then is half of that. So the area of the triangle is equal to 1/2 its base times its height. And that's interesting. It's very useful. I think we've got it. Two things. The area of the parallelogram is equal to its base, the length across here, times its height, the distance between the two parallel lines. And the area of the triangle is half of that. Half of the parallelogram is a triangle. Cool. I think we've got it.